In the interest of both time and interdisciplinarity, I would like to invite all of today's speakers up to the front. We'll pull the chairs out and we'll begin our final panel discussion, where we can ask all of these sorts of questions.
As we organise the panel discussion, I wanted to introduce the person who's going to chair that discussion, a very important figure in green chemistry, Dr. Bob Peoples. He's director of the ACS Green Chemistry Institute, where he drives the implementation of the principles of green chemistry across the global chemical enterprise. Bob holds a BS degree in mathematics and chemistry from Montclair State University in New Jersey and a PhD in physical organic chemistry from Purdue University. So Bob, there he is. Sorry, I can't see you with my reading glasses on. Welcome to the discussion here, and we'll talk for about half an hour, 45 minutes or so, and then have our final break. We'll have a reception in the foyer outside, so we'll have plenty of more time to continue the discussion. So, Bob?
You need these? Well, good afternoon. And first of all, I just have to acknowledge it's an absolute honor for me to be here amongst this collection of intellectual experience and horsepower. And the exciting thing for me is I'm kind of what I call a lifelong learner. And every time I sit through these programs, I learn new things, and that's really exciting and stimulating. I also want to echo what I think most of the speakers said today, and I think John said it very eloquently, and that is really hats off to what you all are doing here at Berkeley. This is a fabulous, fabulous experience you've got going on, and just the tip of the iceberg, and the implications are wonderful as we go forward. So I think for this last, what have we got, about 25 or 30 minutes, I guess, before we're going to wrap up. This is really an opportunity for you to ask questions of the panelists that you've heard today. I think there's no question out of bounds at this particular point in time, and I think the real power here is that we have this interdisciplinary collection of people. So for me, when you're tackling extraordinarily tough challenges, which we certainly are these days when it comes to trying to drive toward a sustainable future, the potential to develop, rich and robust solutions is greatly facilitated by having a very broad spectrum of perspectives, and that's what this group of people represents today. So I am going to open it up to the audience for questions, but before I do that, I am going to ask the panelists, and you can respond if you choose to, all of you, one of you, whatever the case is. I read a comment that was made at a meeting in New York City 2 weeks ago, which was talking about, the monetary value of green chemistry. And one of the speakers said that today, green chemistry is in the DNA of every chemical corporation. And I found that a rather thought-provoking comment. I won't give you my opinion on it, but I'd like to ask the panelists how you feel about that statement.
I mean, I would say not every company. I think that's kind of a stretch. And I would say it's more the companies that are more involved with doing research and development of new products, but there are many companies that are not in that business. So that's one of the challenges of the industry, that it's highly varied. And I also think when you look at it globally, that's not the case. But that's not to say that there isn't a lot of enthusiasm for it in industry at all. It's just a bit of an exaggeration, I think.
Mm-hmm. You're all looking at me. I can't speak for an industry, but I will say that I agree with what John said about us being at a tipping point. I think we're getting to the stage where at least people are having the discussion. They may not all use checklists, and they may not all use criteria that they go through in their either formal or informal processes. But at least I think the awareness is there that there are options that are inherently safer, inherently better, and that that can pay a strategic dividend for a company. And so I think there's at least a growing awareness. I think it may also have been a bit of a stretch to claim that everybody is.
I would agree with that too, that there are pockets of companies that are getting it, and I would argue they are the more successful ones. And in this last economy, we've been at this for a lot longer than this economic dip. What's really interesting to find is that the companies that were doing green chemistry as a marketing ploy kind of gave it up during the economic downturn. And the ones that were doing it from a fundamental DNA perspective actually ramped it up as the economy got hurting, because they saw that that created economic value. But it's more important. I've found that in all the companies that I've been going to and speaking to and giving workshops and things, I get letters afterwards. Most of the chemists are my age. They have kids in their late teens or early 20s. They come home to the dinner table, and there's this uncomfortable, they're learning in school that, mom and dad are working for the evil empire and despoiling the world. And, they get it, but it's a tough conversation. And all of a sudden, mom and dad start coming home and saying, hey, we're talking about green chemistry. Give them a vocabulary to communicate with the general public. And they go from whatever that relationship was to almost a hero-like thing. And so I'm getting emails from people saying, wow, my kids actually asked me what I'm doing at work, and they never have in 20 years. Because all of a sudden it's something that they can relate to in a positive way. And I think that companies are realizing a motivated, hardworking workforce that's inventing molecules is a pretty cool thing to cultivate.
The only thing I would say is, from the vantage point of somebody who served for 2 terms on the U.S. Chemical Safety Board, whose sole purpose was really to investigate when there was a chemical disaster, we had a strong interest to try to find out what were the number of chemical accidents that were occurring across the country. And here, 2011, we still don't keep such national statistics. But all it takes is one in one community to poison the well. So, I agree with John. Boy, wouldn't it be wonderful to tweak the attention of a young person into pursuing this? How satisfying, how creative it would be, how important it would be to me personally to have them do that. But I'll give you a cautionary tale. I had to investigate an incident in Dalton, Georgia, a kind of a mountainous community in the northern part of Georgia. It was the carpet capital of the world. It once had 20 different carpet manufacturers which had agglomerated into 1 or 2, and all of the chemical producers that were supporting that were now facing incredible economically hard times, many of which had not innovated. And so the incident we investigated had released into the community a huge toxic cloud of material that nobody really knew what was happening. It was April, rainy, and hundreds of people had to go to the hospital to be stripped outside in the cold weather and hosed down before they came into the hospital. Now, tell me, what kind of an impression do you think the community had about chemical and chemical safety? And the company had transformed itself into a tolling operation. 2 guys in New Jersey sent them the formula they wanted them to make, and it was the first batch that they were making. So this is really a challenge for us all, in part because I think we would want to be hopeful that a small company could innovate and actually become excellent. But they were innovating with a gun to their head and really did not have the intellectual capital or preparedness or professional extension training to begin to realize there were much better ways of thinking about doing business. We are all at risk if the chemical industry in this country includes such brethren, and we aren't figuring out ways to prevent them from going down those roadways. What are we going to do to make them be more sustainable in their own community and more hopeful, so they would inspire their kids to pursue their venture?
Quick pop.
So I've been really pleased over the last couple of years. A lot of companies I didn't expect, I get in and suddenly discover they have very large green chemistry programs. And that's also on the international scale. So in India, China, the larger companies there are all starting now to build this into their programs.
So there's certainly an element of awareness about all of this that we could probably later follow up on from that point of view. But let's go ahead and open it up to the audience. I see we've already got a question down here, Meg, over here. We got them all over the place, so you guys could just rove around and hit them. Debbie, you got the first one.
Okay. Well, first of all, thank you all so much. It's been an amazing day, and each one of you are exceptional speakers. As a person who works in government, I was intrigued by John's issue that chemicals policy is on the demand side and green chemistry is on the supply side. So that distinction is very interesting. I've been thinking about it. So I'm wondering, from your perspective, in an environment where it's very limited resources in government, what is the role of government on that demand side for green chemistry when it's very unlikely our role will be supplying financial incentives?
Well, I think what it is that you're doing, stronger, clearer, science-based chemicals policy is critical. I think that that's what's driving the demand, and innovation and science will hopefully reach out. Hopefully there is a time when California has, come out of some of its financial woes and can start, funding, the innovative stuff and creating some pockets of excellence, to support actually creating alternatives. But, we are in a world it's kind of strange, from a philanthropic perspective. If I go to a group of people and say, give me money to inject a series of animals with this molecule to show that it's toxic, there are groups that will fund me. If I go and say, I want to make a molecule, okay, and I want to make a molecule, especially if I mention nanotech, there are groups that will fund me. But if I say I want to make an environmentally benign material, you would think everyone would love it. But the way our funding organizations work is it's all about the define of the scope. And so where less than 5% of people mostly get funded in any calling, the first easy criteria is, do you fit the scope? And once someone says, all right, I am a toxicologist looking at toxicity, anyone who's making molecules clearly falls out of scope. If you're making molecules and someone starts talking about toxicology, well, they start falling out of scope. So until we have fundamental funding that is for green chemistry, linking toxicology and making molecules, ironically, everyone loves it. Everyone thinks it's a great idea. But the way our funding organizations work, not in my scope. And so that's an opportunity to start creating specifically scope there.
So I would just build on that. I think there are two issues, and one is certainly policies about funding for research and development. And I think that there really is, across the board, this dividing line between, say, what NIH will fund and what NSF will fund. And if you're talking about health, it's hard to get money from NSF. And if you're doing the kind of thing John does, it's hard to get money from NIH. And so I think there really needs to be much more effort to, get the federal government to do what it always says it wants to do, and certainly, the national academies, when they've looked at the future of science, and that is, more transdisciplinary work, and provide the funding for that so that people are actually rewarded and incentivized to do that. And some people have the incentive anyway, but it's hard to actually realize any gain from that without having the ability to fund it. But I also think that the regulatory side is important, and particularly the fact that these efforts need to be information driven. And how do you know what the targets are for doing work on green chemistry without knowing more about what the actual hazards are? And so, I enjoyed the comment earlier also from the California State toxicologist Melanie Marty, who, I don't know if she's still here, but also the fact that the toxicology information, even the information that EPA does have, can't even share with the state governments, much less the rest of it. So scientists can't even find out a lot of this information if it's held as confidential. And that's very important. One, that it's generated, and two, that people can actually access it.
Great.
So
I guess. No, I was just going to say a couple of things that also occur to me there are some things that governments can do to either incentivize or disincentivize innovation. We have not yet, as a country, stepped up to making the R&D tax credit something that doesn't have to be renewed on an annual basis, right? So, and that's at that fundamental level, we haven't reached that yet. But that's an example. So I would also say that not only on the research side, helping with grants to develop fundamental science, but also on the development side to help de-risk the really expensive part of commercializing a new process, which is the piloting and ultimate large-scale testing if it's something that would require that. So those are the sorts of things on the one side. And I think even establishing consistency and predictability, so the science-based regulations and the coordination of regulations, not only between states and federal government, but around the world. We're starting to see that now in terms of cooperative data acceptance of dossiers between different countries when it comes to the quick substitution of problematic agrochemicals with more benign alternatives. So I think there are things that are very positive and can really help accelerate those things without necessarily costing a lot of money.
Thank you. I saw a hand back up in the back here.
Hi, everybody gave really nice talks today. Thanks for holding this, by the way. My question is whether you think there's any utility. So I guess to preface my point, I think there's a major problem with the public understanding of toxics and hazardous materials, and whether there would be any utility to coming up with some sort of transparent and verifiable sustainability index or certification like the USDA Organic Foods, and whether that would sort of maybe spur the public into having this dialogue and coming to an understanding of toxics and hazards in their lives.
I actually worked on that at one point. We had a consumer labeling initiative when I was at the EPA, and it's a very complicated issue because people have come up with a lot of green labels that just assess on one dimension or another dimension, and you really want to get at the full scale life cycle of a product in order to be able to understand it, because it can be green in one attribute and not another one. And also it's complicated how consumers read these labels and how they interpret those, whatever label you put on them. I wouldn't discourage it. I think it's a good idea. I think there are people who, as somebody pointed out earlier, I think it might have been DuPont, there are people who will select products for being greener. And that if there is a market for it, there ought to be a way of doing a label that's verifiable and that is trustworthy, because you wouldn't want those labels to just be applied willy-nilly. But it would have to be done very thoughtfully, and I'm not really sure who should do it either.
I agree with Lynn that it's very hard to certify a product as safe, unsafe, in the same way you can as it being organic, not organic. But there is the example of LEED certification, and there are certain kinds of certifications you can get to the process of the development or the way that the product was developed in the process. That may be a start, but there's a whole public education issue on top of just the certification and the label as well.
I just have two things. The first one is the public desperately needs this tool. We need to find out how to do it. The problem is there's such a diversity of molecules, diversity of kinds of materials, to find some one-size-fits-all way of standardizing, looking at carpet, looking at automobiles, it's mind-numbing to think that could be done. Doesn't mean it shouldn't be done, but it's tough. But my more important caution is if you accept my proposition that 65% of the things haven't been invented yet, any standards exercise is usually consensus-driven with people that have a vested interest. If the standards are set around what exists today, we're back to, as Lynn pointed out, almost an inhibitor to innovation, because the standards were defined by what we can do today. And green chemistry is a research problem of tomorrow, so we don't want to, in some accidental way, handcuff innovation by defining only what we can do today as being good, bad, or ugly.
And absent a government action, the private sector will take over. So look at the case study of Good Guys and how that has evolved and how quickly people have prepared an app on their iPhones to be able to go into a grocery store, scan the product, and come up with a relative ranking system for what's the best kind of toothpaste to buy. The black box of that Good Guide system should be of interest to us all for how accurate is it and how does it work. And is it truly driving consumer demand towards the better products? Totally private sector without transparency is as problematical as putting it in the portion of EPA that's locked down with all the information.
Good
Nobody
point.
knows what they know.
Very good point. Another in the center over here.
Hi. So I come at this from an advocacy perspective, environmental advocacy, and I have actually two questions, but they're very related. We're hearing that, Rome wasn't invented in a day. We can't just go out and produce the perfect product or the perfect chemical, and it's going to take time. We have a lot of toxicology to learn. We have a lot of time to develop a product for a specific application, et cetera. So my two questions are this, is that as we're trying to create things that are usable in society, and I'll use your example of the solar panel, where, it's good. We're making solar panels. We need to save energy, but some of them, have toxic chemicals in them. Are there some chemicals that should not be in the toolbox, the green toolbox, because they are so horrible that we shouldn't, even if we're saving tremendous amounts of energy, we shouldn't be using them? So that's one part of the question. And the other part is, we hear different time frames. We've got scientists that are saying, no, it's going to take a certain amount of time to come up with the toxicology or to develop a product, at a company. And some of that information is, people trying to make a good estimate and provide good information about what those time frames are. Sometimes they're very self-serving. An industry may not want to make a change. Oh, it's going to take a long time. And that does influence political and legal decisions. So how do we decide what are the right time frames to really do the work we need, the science we need, but not bog ourselves down by studying something to death and not making progress? So,
do you want to hear my bad chemical list?
Yeah.
So certainly, polychlorinated biphenyls, which we have banned, except we make them as chemical standards so that we can find them in things. So we still have to make some of them, or we can't detect them. So that's a funny thing. But dioxins, certainly. Lead, meaning I think we need to replace the lead acid battery, please. If chemists can figure out a way to do that. I personally am not too crazy also about the use of certain other metals, or generation of them, mercury and cadmium and arsenic. They have no benefit biologically. They're very persistent. DDT, I think we need an alternative for DDT for malaria control, and it needs to be, it needs to be affordable, it needs to be easy to use, it needs to be non-toxic to the people who live in houses that are getting treated for malaria. And so, I certainly have a list of things that are like that. But I would say most of the things that I know about that I wouldn't want to be exposed to, I don't want to be exposed to benzene. I don't want any benzene in my home. I don't want my daughter breathing benzene. Every time I pump gas, I'm breathing a little bit of benzene. I'm aware of that. And I'm not saying ban gasoline, okay? You didn't hear me say that. So, I didn't say that. So, but we can minimize exposures to it. It used to be in all kinds of things that I could have contact with, my family could have contact with, that it's not in today. Workplaces, all kinds of environments. So most of the things that I consider to be bad actors, we can minimize the exposures to them through more sensible use. But even that gasoline, I believe someday we will drive vehicles or be transported without using the gas guzzler. I believe that.
John.
I think it is difficult, though. This is always the trade-off. Is there the absolute answer there? That some substance, and DDT is a good example of one where, different groups have made different relative gradations of decisions. Yes, it's okay. If there's an epidemic going on, you have to do something to intervene. Or it's okay to prevent children from dying from malaria, in a house, even though it has these harmful effects. But the flip side of that is that there are a lot of products in major use that maybe aren't serving purposes that are beneficial. And I think of something like triclosan, for example, that is a big market chemical. That's an aspect that we haven't really addressed. Is the scale of use and the scale
But it's
of
used in
associated-
operating rooms to sanitize surfaces.
Yes, no, I mean, for
And
certain
so
uses, it's...
That's why I didn't name it, because I wouldn't say ban it. But, on the other hand, yeah, why is it in toothpaste? No good reason for that. You're right.
John?
It's interesting because this discussion is exactly why green chemistry is so important. These problems, we can debate whether this is bad enough to ban or this is bad enough to ban. You know how to make the problem go away? Have 10 safe alternatives that are cost effective and have similar or better performance, and let the market make the bad go away. And so the whole thing is not to replace all of the discussion of what to ban and not to replace it, but if we could have an equal effort of coming up with the alternatives, it makes the banning job so much easier when an alternative is readily available. And so what's happening at a much slower rate is the invention of the alternatives. So the discussion of ban this, don't ban this, ban this, don't ban this, as little as that is happening, it is still outpacing the let's invent the alternative. And so that the vision of green chemistry is to have accelerate the banning discussion, accelerate it, improve it, and do more of it, but meet an equal effort of coming up with the alternatives to help that process work.
So the question there is, why aren't there more people attempting to eat somebody else's lunch when they have a product out there that is clearly raising questions? What slows us down from accelerating that process of innovation?
The scientists aren't learning toxicology. How can you invent something you don't understand?
Well, I certainly think there's an element of awareness here, because I suspect, like you, I would estimate that our institute somehow touched about 10,000 people last year. And I always ask the question, have you ever seen this definition of sustainability, green chemistry, or the 12 principles? And I would tell you on average, 95+% of the audience will say no. So I do think we have a huge communication challenge to, number one, raise awareness, and then once you raise awareness is to start the education process. And that's what this is all about from a catalytic point of view. Now, I have to tell you that this conversation is tremendously exciting and stimulating, and we could go until 10 o'clock with no problem. But in the interest of the time commitment, I think we said we'll do one more question, and I think I saw a hand over here. Yeah.
I have actually received
This one's been up for a while.
Okay, very good.
Thanks a lot.
A little hard to see with the spotlights up here.
So I had a kind of a different question that maybe will point out a pink elephant in the room or something. But you were concerned, John, about the declining interest in science and the fact that maybe kids aren't as interested in science as art or something else. And I have a couple kids that have, one's in college now, one's going into college, and the things I hear them concerned about are, they look at me as a scientist and they see layoffs in the industry and they see outsourcing in the industry, and they're kind of running away from science. They're worried about their future in science. And I wonder how much, I heard the Dean of Chemistry this morning talk about we were going to include the Haas School of Business in our green chemistry efforts, and I was excited to hear that. I wonder what we're doing to communicate all of this to our business leaders and to our business students to make sure that they're on board and they see examples like Warner Babcock and they say, hey, yes, this is the right way to go, rather than looking for maybe lax enforcement or lower business costs related to personnel and maybe an emerging economy.
Well, I guess my view, and people much more sophisticated than me can tell me if I'm right or not, is that across the planet, chemistry jobs are not declining. They're going from the United States. All right, and so the need for new materials, the need for business to have new materials is increasing globally. It's just they're going elsewhere. And so green chemistry offers that competitive advantage to perhaps be more competitive, to actually grow the economy back in the United States. But this is a global problem, and we can't get too patriotic about this. But at the same time, I would argue that the jobs are not vanishing; they're just going elsewhere. And green chemistry is perhaps the way to retain them.
I think that's part of it, but I also think that, and you might want to check with your kids to see what they say, but I know what I see with my kid who's 14, and that is the way that math and science is taught today is as boring as can be. And the math textbook that she has is nothing but an extended apology for we have to teach you this math. So we're going to show you, we're going to show you how it's really relevant to the real world, and we're going to throw in U.S. News and World Report articles and all kinds of stuff that has nothing to do with math. And the beauty of math, what made me love math when I was a kid, is absent, complete from this, because this is kind of, everybody's got to go through this and we're so sorry, And, is it any wonder that they come out, and our math scores are low in comparison to the math scores of kids around the world in far poorer countries where, instead of a 500-page book that has all this faulty-wall, they've got, they're teaching them math. And, we're just not doing it very well. And I think we need to take some responsibility for that, those of us in universities. I love what John's doing, going to teaching. We need to pay more attention.
Jerry.
Yeah, I was just going to say I have a daughter who's going to a high school in Northern Virginia that's been ranked for the last several years as the #1 in U.S. News and World Report, Science and Technology School. And I will just tell you from the very limited personal experience of caring for your daughter, being trained as a scientist, having some hopefulness that that might appeal to her. Freshman year, wonderful integrated biology, technology, and English curriculum. She loved biology. Sophomore year, AP biology, right? Because this is a validation of how do you get ranked #1 by U.S. News and World Report. Teaching to the test is just deadly. Her enjoyment of the field of biology diminished dramatically because the teacher was teaching to a test. So what does that say about us? Sophomore year, she's taking AP biology and she didn't like biology. She loved chemistry. What an amazing teacher she had. Creative, just enthused. The first chemistry class she was ever going to get for a whole semester. She loved chemistry. Junior year, AP chemistry. She fell out of love with it. So what is wrong with this system if the credit to get into college is proving that you can take the most advanced test and get the highest grade? And she got 5s in both of them. But what a risk to think about that the love of the science may have been diminished by that hazing experience. So what are we doing, folks? Are we going to change this around?
So we've opened a deep vein here. I think Bob's got another observation.
Yeah, well, no, I just agree with John. Is if we look at it locally, we're in trouble. If we look at it internationally, we're in pretty good shape. There's a bunch of kids around the world who are working their butts off and are learning science and doing really, really well. We got to make sure some of those come to the U.S.
They are.
So in the interest of our time commitment, I'm going to bring this section to a close. But as I do that, I want to leave you with the following thought, and that is, we are talking amongst ourselves here, and this is really powerful for stimulation and creative thinking, but we don't need to spend all our time talking to ourselves. The real challenge is talking to the folks outside of this room that we need to raise the awareness of. And I think one of the most powerful elements of this program at Berkeley right now is the fact that it is interdisciplinary. And in fact, bringing the business community into this is essential, because at the end of the day, we can invent the best green chemistry, the best green engineering the world has ever seen. But unless it gets reduced to practice, it's of no benefit to society. And I would submit to you that most often it's not the chemists and the engineers that make the business decisions to invest the new capital in the technology. It's the C-suite, right, the corporate executives. So reaching out to the business community and raising that awareness and giving them the case study examples of the real power and the return on investment and right to operate in their communities around the world is another lever that we can pull to have a big impact, to go from what I think today is ad hoc implementation of green chemistry to systemic implementation of green chemistry on a global basis. And it'll get us to John's aspirational goal of stopping talking about green chemistry in the future, but just talking about chemistry, because that's the way we do it. So thank you, Marty, Mike, Megan, Bob, for the invitation to be here, and for all these wonderful people today. It's been an absolute pleasure.
Thanks very much, Bob. I want to thank the speakers again for coming here to the conference today, for giving outstanding talks and for participating in this discussion. So thank you again. Again, thank everybody who helped in the organisation of this symposium today. Thank you very much to the Philomathia Foundation for funding this day. I want to leave you with some questions. We clearly throughout the day have come up against a lot of issues that we still face. We have a long way to go. This transformation, I think, will be a generational transformation. It's not going to happen overnight. I think that's apparent from what we've seen today. We're taking steps here at Berkeley now to try and do this. But as Bob said, this has to go out from Berkeley, from Yale, from the Warner Babcock Institute, from Oregon, from York, out into the wider world to really make a difference. It used to be a slogan of DuPont, better living through chemistry. I got into chemistry because I heard that slogan. I still believe that. I still believe that chemistry is a force for good. It does amazing things. We have problems. Better living for green chemistry might be a better slogan right now. I don't know. Maybe that adjective is what we need the public to hear, to listen to chemists again, and to trust them with the work that we do. Eventually, as John Warner said, it'd be nice if we didn't have to talk about chemistry. Sorry, if we didn't have to talk about green chemistry. We didn't have to talk about green chemistry. Maybe one day we can go back and say better living through chemistry, because folks, chemistry's not going away. We are chemistry. We live because of chemistry. We are chemicals, and we need chemistry, and we will continue to do chemistry. I hope we're going to do better chemistry in the future, and maybe the way to get there is through green chemistry. So thank you to all the audience members for your participation, for your attendance today. Here at BCGC, we welcome interaction with everybody in the room, outside, in the broader community. We need you in order to engage in research, education, and the wider engagement of those activities across the state, across the US, and the outside world. So again, thank you for coming. It's been a great conference. I hope you've enjoyed it.